In this video, I will talk about basic probability concepts. Probability helps bridge descriptive and inferential statistics. Probability principles are the foundation for probability distributions, mathematical expectation, binomial and Poisson distributions. For example, probability can be used on intent to purchase survey responses and associated follow-up responses to answer many purchase behavior questions. The sample space is the collection of all possible outcomes of a variable. For example, when you roll a die, your sample space will be all six faces. If you play cards, all the cards will be in the sample space. You have 52 cards. Each possible outcome of a variable is an event. You have a simple event, and that's the event described by a single characteristic. For example, a day in January from all the days in 2019. A joint event is an event described by two or more characteristics. A day in January that is also a Wednesday from all days in 2019. And then a complement of an event A, which is denoted with an A with a little apostrophe right after it. These are all events that are not part of event A. For example, all days from 2019 that are not in January. Probability is the numerical value representing the chance, likelihood, or possibility that a certain event will occur. Probability is always between 0 and 1. An impossible event is an event that has no chance of occurring. That probability is 0. A certain event is an event that is sure to occur. That has a probability of 1. Mutually exclusive events are events that cannot occur at the same time. For example, randomly choosing a day from 2019. You can choose a day in January or you can choose a day in February. Those two events cannot occur at the same time. You cannot have a day and that's in both January and February. So they're considered mutually exclusive. Collectively exhaustive events means one of the events must occur. The set of events covers the entire sample space. For example, you randomly choose a day from 2019. A is a weekday, B is a weekend, C is January, D is spring. So events A, B, C, and D are collectively exhaustive, but not mutually exclusive. A weekday can be in January or in the spring. Events A and B are collectively exhaustive and also mutually exclusive. So let's go back and look at that. When we say collectively exhaustive, that means one of these events must occur. So if I randomly choose a day in 2019, it's either going to be a weekday or a weekend. So you have no other choice. So one of these events have to occur. They don't necessarily have to occur in January. Picking a day does not have to be in January or spring, but it's either going to be a weekday or a weekend. They must occur, but as you can see, A and B are also mutually exclusive because you cannot pick a day that's a weekday and a weekend day. Okay, so that's why they're mutually exclusive. So there are three approaches to assessing probability of an event. The first one is priority, and that's based on prior knowledge of the process. So probability of occurrence is x over t, where x is the number of ways in which the event can occur, and t is the total number of possible outcomes. Empirical probability is based on observed data. So the probability of that occurring is the number of ways in which the event occurs divided by the total number of possible outcomes. And then subjective probability is based on a combination of an individual's past experience, personal opinion, and analysis of a particular situation. So let's look at look at an example of priori probability. When randomly selecting a day from the year 2019, what is the probability the day is in January? Well, we know there are 31 days in January, and we know there's 365 days out of the year. So the probability would be 31 over 365. An example of empirical probability is, let's look at this example. Find the probability of selecting a male taking statistics from the population described in the following table. Well, if you look at the table, we have males and females, and we have going across the top taking statistics or not taking statistics. So the probability that you're male and taking statistics is you have 84, and you have a total of 439 people that you looked at. So it will be 84 divided by 439. Subjective probability differs from person to person. What is the probability a new ad campaign is successful? A media development team assigns a 60% probability of success to its new ad campaign. The chief media officer of the company is less optimistic and assigns a 40% of success to the same campaign. The assignment of subjective probability is based on a person's experience, opinions, and analysis of a particular situation. Subjective probability is useful in situations when an empirical or priori probability cannot be computed. So you can summarize sample spaces into contingency tables. This is an example of a contingency table. Um, this survey dealt with buying a TV. So they asked people, did they plan on buying a TV when they walked into the store? And when they walked into the store, did they actually buy a TV? So you can plan to purchase a TV, and when you get into the store, you actually purchase, or you can plan to purchase, get into the store, and not purchase. You can also not plan to purchase, but when you got into the store, you purchased, or you can plan not to purchase a TV, and when you walked in, you actually did not purchase a TV. So that's what this table indicates. As you can see, they have a total of 1,000 people that they looked at, that they surveyed. So simple probability refers to the probability of a simple event. The probability that you plan to purchase a TV, or the probability that you actually purchased a TV. So if you plan to purchase a TV, you'll look at this column, this row here says yes, you have 250 who said that they plan on purchasing a TV out of 1,000. The probability that you actually purchase will go down this way. And as you can see, that's 300 out of 1,000. Joint probability refers to the probability of an occurrence of two or more events. This is considered joint probability. For example, the probability that you plan to purchase and you actually purchase, or the probability that you plan to purchase and you did not purchase. So if you plan to purchase and you actually purchase, that will be this number here, 200. You plan to purchase, but and you also actually purchase. That's 200 over 1,000. You can also plan to not purchase, but you actually purchase. Okay? Sorry. You plan to purchase, but you did not purchase. So that will be 50 over 100. So this should be this way. No purchase. Probability that you plan to purchase and you did not purchase. That would be 50 over 1,000. You can also compute marginal probabilities via joint probabilities. For example, the probability that you plan to purchase is the probability will be here, 250 over 1,000, but you can do it via joint probability. So if you look here, probability that you plan to purchase and you actually purchase, so that's a yes and a yes. That's 200 over 1,000. And the probability that you plan to purchase but you did not purchase is 50 over 1,000. So you got 200 over 1,000 plus 50 over 1,000 will give you 250 over 1,000. So when you have a contingency table, your joint probabilities are within the table. Your simple probabilities are along the edges, along the ends, in your totals. But the joints are within the table. So once again, probability is the numerical measure of the likelihood that an event will occur. The probability of any event must be between 0 and 1. The sum of your probabilities of all mutually exclusive and collectively exhaustive events is 1. If A, B, and C are mutually exclusive and collectively exhaustive, then the probability of A plus the probability of B plus the probability of C is equal to 1.